Hey, I'm John Morello, Vice President of Product for Prisma Cloud Compute at Palo Alto Networks. Today we're going to talk about the age of the cloud-native security platform. Cloud-native is a set of technologies that's recently come about over probably about the past 5 years or so that's really focused on enabling much faster innovation and iteration of software amongst organizations of all sizes and stripes. Organizations that are using cloud native are really taking advantage of technologies like service meshes, containers, serverless, immutable infrastructure. If you think about the way that you build a modern application by consuming a set of services from the cloud provider and building components of your own application using these technologies that are really easy to integrate with the CI process and easy to deploy onto these modern compute platforms, that's basically what cloud native is. You can see here the actual definition directly from the Cloud Native Computing Foundation. Cloud native is something that you really see a lot of growth in right now as well. You can see some pretty impressive statistics here about the adoption of it. And it's not just an enterprise technology. You see companies and customers across all sizes and shapes and industries, governments serving their citizens, media companies using it to stream video, banks using it for doing loan processing. So it's not an industry-specific sort of technology. Cloud native is also something, though, that because it's so virtuous in terms of what it offers, it's really being used by a lot of organizations to service the kinds of needs that are driving them to this digital transformation in the first place. You probably heard the quote about every company becoming a software company or software eating the world. Really speaking to the notion that everybody has to develop a competency in developing software, not just tech companies. I mean, if you think about the way that you choose your bank or the way that you might choose where do you shop or what kind of car you drive even, a lot of that's driven today by the tech experience that you get with it. And that tech experience requires software innovation. Cloud native is the tool set that enables that mass software innovation. When you think about cloud native, remember the whole notion of cloud native is obviously leveraging cloud, and there's really 3 layers to cloud native applications. Obviously you have the physical environment, the data centers, the silicon that you're actually building those applications on, and in many cases that's from a public cloud provider. That's Amazon and Azure and Google Cloud and so forth. That physical environment there obviously has to underpin everything, but in a lot of cases organizations really aren't interacting with that in a direct manner. Then you have the service plane that sits on top of that. That's what exposes that physical environment in a way that it can be consumed by you as a customer. The service layer is where you've got things like load balancers and virtual machines and serverless functions and blob storage and file storage and so forth. These are finished services that are built on top of those underlying physical capabilities that the cloud providers offer. And when I say cloud providers too, to be clear, we're not talking exclusively about public cloud providers. This physical environment could just as easily be behind your own physical data center walls as long as you're operating in a way that really emphasizes that automation, the ability to have immutable infrastructure and to kind of treat all of your infrastructure as code. At the very top layer is the compute. So if you've got the underlying infrastructure, you've got the services that you use to expose that infrastructure, compute is the layer where you're actually building your applications, the software that you engineer yourself, or maybe that you take from a third party, but the actual applications, the things that provide value to your organization, that service your users or allow you to sell your applications or whatever it is that you're building as a company, that compute layer is where you actually are really doing most of your innovation. Service is kind of commoditized in the sense that it's something that is available to any customer of the cloud provider, and obviously all the cloud providers have fairly physical infrastructure. They're a fairly similar physical infrastructure. And so compute is the layer where you really do your own software innovation to provide you that competitive advantage and that differentiation that we were just talking about. Compute is something that can be delivered in a wide variety of form factors. We've written a couple of times over the years about this notion of a continuum of compute options for cloud native. And that really speaks to the notion that cloud native is not just about containers, it's not just about serverless, and it's not even about a journey from one side of this continuum to another. It's not about saying that everybody that's on VMs today needs to eventually progress to be going on serverless in the future. Rather, it's about a set of choices for your infrastructure, for running that compute capability on your infrastructure, a set of choices that have different strengths and weaknesses. And what we see in the real world is that wise organizations are not choosing one of these, but are choosing an all of the above approach. You might have some things that are better suited for VMs, like a legacy database that's proven and works well on that virtual machine, whereas you might have other parts of your application that you run in serverless functions, like you're building a new mobile front end. So it's not about saying that I want to have one of these application options from compute for the compute continuum, but rather which ones do I want to choose for a particular kind of workload within my environment. And because of that, I don't think anybody would say that they really want to have a different security tool for each one of those different continuum options. So therefore, we want to have a cloud-native security platform that gives customers the choice to run their applications with whatever one of these compute options that makes sense, but to have a consistent security experience and set of capabilities that spans across them. Cloud native as a technology set, like most technology sets, is not something that's either good or bad from a security standpoint. If you think about the waves of evolution in computing over the past 20 years, as you went from client server to virtualization to IaaS and now to cloud native, all those things represented change. Some of those changes are easier from a security standpoint, some of them are harder. Some of them create more risk, some of them give you the opportunity to reduce that risk. And cloud native is really no different. With cloud native, you've got a few things that really make security more difficult. One of those things is the fact that security is now much more ephemeral. The entities that you're protecting are going to come and go with a much greater frequency than they have in the past. If you think back to your traditional infrastructure, you might run a virtual machine for months or in many cases even years without actually redeploying that virtual machine. It might have the same IP address and DNS name for that entirety of its operation. With cloud native, containers can come and go, serverless functions can come and go every hour, every minute, sometimes even every second when you think about serverless functions. So that the environment itself that you're protecting is far more ephemeral, far more dynamic than what it was in the past. You also have a lot more stuff that you're dealing with. So in the past, you had a set of virtual machines, and that set of virtual machines in many cases was pretty static over time. Maybe as you added a new application, you would add a new virtual machine, but the number of things that you had was relatively controllable. You could use a lot of manual effort to still effectively manage that. Whereas with cloud native, when you decompose your app into a set of microservices, you might go from having an application that runs across 4 or 5 VMs to one that now runs across 20 or 30 or 50 containers and serverless functions. And so in addition to those things changing a lot more frequently, you just have a lot more of them that you have to deal with. And then security of those things is a lot more in the hands of the developer. In the past, most organizations would have a development team and an operations team, and the development team would build an application. They'd give it to the ops team who would deploy it, and that ops team would then be responsible for using a tool like Qualys or Tenable or something to scan that environment and find a vulnerability, and then some other tool to push a fix for that vulnerability. In this world, because the developer is basically building a sealed application, the exact same set of bits on their desktop that they push to a cloud registry that they then run in a container in production, there is no opportunity for the operations team to fix a problem after it's been discovered. So it's really much more in the hands of the developer to find and fix those problems early on in the life cycle of the application. And all three of those things are quite a bit different than the old world. Again, not that cloud native is less secure or more difficult, it's just different security challenges that you deal with. But all that is not necessarily bad. Cloud native also brings with it some characteristics that make security easier, at least give you the opportunity to build a security tool and a security posture that emphasizes more automation, a more efficient approach to doing that. And specifically, that's the fact that cloud native applications are more declarative. So if you think about an application that you might run in a container, for example, that container runs an image is composed of layers are described in a Docker file. You can really utilize software to understand exactly what that application should be doing in a really trustworthy way. Those apps are a lot more minimalistic. So instead of having something that might be, tens of gigs worth of data in a VM image, you're now talking about something that may just have a few hundred megs or, maybe just a few tens of megs worth of content in a container image or in a serverless function. So it's more practical for software to be able to understand what that application actually does. And finally, the whole notion of cloud native is that those applications are more predictable at runtime. Rather than in that old world where you would deploy that virtual machine, you go in there and you change it by installing updates or reconfiguring it. In this world, that application is going to do exactly the same thing from the first time that you deploy it till the time that you retire it. If you want to change the functionality, you simply redeploy a completely new version of that. And that predictability enables you to build security tooling that can more easily identify what's normal and thus prevent what's abnormal. Compute, though, is just one of the layers for cloud native. You know, we talked earlier about the notion of that service plane layer and that physical layer that's there, but the result of that really kind of layered concept is that you end up with a lot of complexity, a lot of abstraction within the environment. There's a lot of interdependency as well amongst the layers. You know, you don't really know as a user whether or not the container that you're running your application in is running on one particular VM or another particular VM within a cloud provider. You certainly don't know whether or not it's running in one physical rack or another, or what routers it progresses data through. And all of that means that you need to have a more holistic way of looking at the application than just simply looking at that compute layer. So when we think about the cloud native, you've often hear cloud providers talking about the notion of a shared responsibility model. And that maps really well to this three-tiered model that we talked about. In their vocabulary, they basically think of two layers, you know, theirs and yours. What we're saying is that there's actually a little bit of differentiation. Your problem is actually composed of two different layers. So those three tiers that we talked about really map back to the notion of a shared responsibility model that all the cloud providers have. So their commitment to you is how they secure the underlying data centers and the services that they run in those data centers. Your problem, what you have to focus on, is how do you configure those services securely, and then how do you securely run compute on top of them. So much as Amazon can be running EC2 in a completely secure manner based on what it guarantees through its SLAs and its security attestations, you as a customer could still have a very insecure configuration of an EC2 instance if you choose to run it within a VPC that has full unfiltered internet access, for example. Similarly, even if you're securing the configuration of that VM properly, you could still have an overall insecure state if inside of that VM you're running an operating system that has critical vulnerabilities. That's the compute layer part. And that's why it's really important to have something like a cloud native security platform that gives you that visibility through both of the layers that are your responsibility to deal with. In the past, the way that organizations would get that visibility was through a hodgepodge of different tools. You might have one tool to provide that service layer visibility that was often referred to as cloud security posture management. At the top layer for compute, you had things for workload protection and source component analysis, and maybe even some other things in there to protect the actual running applications. But the problem with that approach is you end up with a lot of difficulty managing multiple, maybe 3, 4, 5, or even more security tools that don't talk to each other, that don't share data easily, and that are not really programmatically accessible. Things that expect a person to go and click through a user interface to configure them and to manage them. And so fundamentally, this approach of trying to have this very complex, multi-layered cloud-native environment and to address securing that with a lot of different technologies from different security vendors really makes it much harder for you to do your job and makes it more difficult for you to get the security outcomes that you want. And that brings about the age of the cloud-native security platform. A cloud-native security platform is a comprehensive set of security tools that's really built as a true platform. A true platform being something that's automatable. It's got an API available for everything. It's focused on securing the application and all of the components that go into it, the compute stuff that you use, as well as the underlying services that those compute layer components are resilient or reliant upon. For example, if you're running your application and that application is talking to a back-end managed database, you want to be able to protect not just your application code, but to also make sure that it's securely connecting to and that database is securely configured so that the entire stack that you're relying upon is done properly. It's also really critical that security be throughout the development lifecycle, that you're not just securing the application in production, but that you're securing it all the way back to the point that it's being built by your developers and tested in those early environments. And that speaks to the point that we were talking about earlier, in that security is now largely in the hands of the developer. If you're going to have a cloud-native security platform, it can't just be focused on runtime. It's got to go all the way back to those developers and inform and help shape what they do day to day as well. So if you think about what that security platform looks like, that CNSP, that broad set of security capabilities spans both of those layers of the stack. How you configure the services, what you run on them, and again, across the entirety of the lifecycle of the application. Not just when you build it, not just when you deploy it, but throughout that time, and to enable all those time elements to inform each other. As I build my application development, we can learn things about how it should behave in production and use that to inform the security model at runtime. At runtime, if we find vulnerabilities in the application, we can use the metadata of the application to automatically go back and inform the developers of it that they have a problem that they need to fix. And that lifecycle-based approach is really a fundamental difference between a cloud-native security platform and what you have with point-based solutions. So why a CNSP? It's that notion again of having that full lifecycle view. Something that's, that's not working well today is the notion of a security platform or a security tool at least that's not automatable. You want to make sure that the security tools that you're using have the ability to be wrapped in a set of automation such that you can treat the security tool like code as well. Traditional security tools didn't provide that. They really focused on primarily like a user interface sort of experience versus one that was API enabled. We talked about the notion of having multiple security products, that idea of security product fatigue. If I've got to look at 6 or 8 different interfaces to secure a set of applications that are all kind of doing the same things or at least providing the same sort of value to my organization, it's a much more painful sort of experience than if I have one unified platform and one unified API that I can work with. The tools themselves are typically not really built to protect the application of the data. They're designed to protect the infrastructure or the network or, like a slice of it, not the entirety of what you're looking at, which is a key aspect of the CNSP, is to traverse those layers. And then finally, you probably have seen a lot of the cloud providers have some security tooling that they've introduced, things that provide you some visibility and some awareness, but very few organizations today are completely beholden to a single provider. Most people are trying to be wise and hedge their bets and take advantage of capabilities that exist across multiple cloud providers. So multi-cloud isn't just sort of this idea that I've got some stuff in my own data center and some stuff in one cloud provider, but increasingly means that I've got stuff in many different public cloud providers. I don't want to have different security tools and different security practices for each of them, so that CNSP doesn't need to just cover those first 2 layers, but it needs to be able to cover those first 2 layers across all the different cloud providers that I might run in. So if you think about what that security definition, those capabilities that CNSP provides and how they relate to that definition of cloud native itself, that notion of being able to integrate across the lifecycle, something that's built into your CI process, that leverages that knowledge early in the build process of your applications to help secure the app, that's a fundamental aspect of a CNSP. That the entirety of the CNSP, how do you configure it, how do you set it up, how do you get data out of it, is entirely automatable. In other words, if I choose to be able to, or if I choose to manage my environment through automation, through like a GitOps approach, I should be able to do that for my security tools as well without having to rely on manual interfaces or human beings clicking buttons to be able to secure the configuration of that entire estate. And then finally, it should run everywhere. Not just, again, in a single cloud provider, not just on a particular part of that continuum of compute options, but across everything from hosts to containers to serverless, across Azure and AWS and GCP and even my own data center. Those capabilities that a cloud-native security platform provide can be very wide and varied. It's not just simply about, again, runtime defense or about vulnerability detection in the CI process, but it's all the things you see on this slide across both layers of the stack there. How do you provide runtime defense so that a malicious actor is not able to run arbitrary code if they find a vulnerability? How do you find that vulnerability in the first place and prevent it from being deployed? How can you do things to micro-segment the network so that you limit the blast radius of compromise? The capabilities of a cloud-native security platform are designed to be very broad by definition because, again, a core aspect of a CNSP is that it's comprehensive and that you don't have to have multiple point solutions. So a CNSP should provide all the key functionality that you need to secure all those applications, again, across all the different cloud providers that you run in. And so to summarize, there's kind of a way to compare and contrast the old world, the pre-CNSP age, with the new world, the age of the cloud-native security platform. In the old world, security was very much focused just on production. In the new world, again, it really is important to integrate that all the way back in the development lifecycle because the developers themselves now are much more accountable for the security of the application. In the past, you had real silos for the compute, the application, and then the infrastructure that you ran it on. You had a different thing for application security than you did for data security, than you did for network security. Now you really need to have that integrated platform that protects across all those places so that you don't have that security product fatigue and different things that you have to use for protecting just different components of the same application. The old world was very perimeter focused. You probably have heard that notion of like the M&M model of security, a hard shell and a soft, chewy center. What we're trying to get to now, because clouds don't really have edges, is something where security is pervasive and really focused on the application, not relying upon data flows in and out that application to go through a particular device. Your security should follow your application throughout its life cycle and again across all the different places where you might run it. And finally, the old world was really focused on the notion of a lot of manual operation. Somebody sat in front of a product interface, somebody clicked buttons, the data was very proprietary and kind of locked up in that system. Whereas in the new world, the idea is to stress all of that through open APIs, through automation, through open data contracts, so that the way that you set up and configure and get data out of the system can be entirely automated from end to end. So thanks for joining us for this discussion of a cloud native security platform. I hope you found it useful, and see you on the next show.